Why did she stop replying? You might never get a clear answer from her, but your own behavior leaves a trail that a machine can read. This patent, number J7791512, is for an AI credit scoring system originally used by banks to decide if someone will repay a loan. Today, we're applying that same technology to a completely different question: will this person get a second date? On the right, you can see the score from our live demo. Before adjusting 3 habits, the second date probability is just 0.31. After making these changes, it jumps to 0.78. Soon, I'll walk you through exactly how this AI works and how these improvements are identified using Explainable AI with LightGBM and SHAP. Let's dive in. This patented AI credit scoring system combines 3 powerful features that work together seamlessly. First, it learns directly from past data instead of relying on rules someone wrote by hand. You simply feed it records of past outcomes, like who got a second date or who defaulted on a loan, and it identifies patterns all by itself. Next, it returns a precise score between 0 and 1, reflecting the probability of a positive outcome, which gives you a nuanced ranking rather than just vague categories. Then, unlike most systems, it explains its decisions. Using SHAP values, it breaks down the score to show exactly which factors pushed the score higher or lower, so you understand the why, not just the what. What's really clever is that this model stays the same regardless of the application. All that changes are the input variables, like income and late payments for banks, or message frequency and reply times for dating. Same code, same model, just a different dataset, and that's the whole secret behind its versatility. Here's the input data we feed into our AI credit scoring system. Each row represents a different person, with columns showing messages per day, the first reply time, the reply gap after the second message, how much they cared about their outfit, and whether a second date happened. Take a close look at female D. She sends 18 messages daily and replies within 5 minutes, faster than anyone else here, yet she didn't get a second date. This tells us that neither message volume nor reply speed alone are the key factors. The model is designed to uncover the real signals behind these interactions. Let's see what insights it reveals next. This AI credit scoring system works in just 3 simple steps. First, we train the model using past records. The script reads these records and builds a LightGBM model that can distinguish between second dates and dead ends. Then, in step 2, when you bring in a new person, the model gives you a score between 0 and 1. But the real value is in step 3. Here, SHAP ranks each input based on how much it influenced the score, and we highlight the top 3 factors. This step is crucial because while a score alone tells you if you lost, the top 3 reasons show you exactly what to change before Saturday. First, we need to clean up the data to make it usable for our AI model. The model can't understand words like, within 5 minutes, so we convert these time phrases into numbers representing minutes. For example, within 5 minutes becomes 5, and next day becomes 1440. Similarly, we assign numerical values to outfit care, with 2 meaning every date, 1 for sometimes, and 0 for never. Next, we separate the answer column, which is whether there was a second date, into a variable called y. This is important because the model's job is to predict this outcome, so it cannot be part of the input features. Finally, we split the data so that 20% is held back as a test set. This test set is crucial because it allows us to evaluate whether the model actually learned meaningful patterns or just memorized the training data. Here we see the core of our AI credit scoring system, powered by LightGBM. Instead of manually defining rules, the model learns by itself from the data. We start by setting key parameters like the learning rate, which here is 0.05 to ensure each decision tree we build is cautious and doesn't overfit early results. Then, we train the model on historical records, letting it build 400 small decision trees, each one improving upon the previous. The objective is binary, meaning it predicts a yes or no outcome. After training, we validate the model against unseen data, using the AUC score to measure how well it distinguishes positive outcomes from negative ones. Finally, Once we're satisfied with the model's performance, we save it to a file to make it immediately available for deployment in the web app. This entire process allows the system to continually improve its credit scoring accuracy without manual intervention. What sets this patented system apart from a regular classifier is its use of SHAP values to break down the final credit score. SHAP assigns a contribution value to each input feature, showing how much it pushed the score up or pulled it down. We then rank these contributions by their absolute size, because both positive and negative impacts are equally important. We keep only the top 3 factors for clarity. For example, in the real output shown here, the features outfit care and reply gap pulled the score down by 0.24 and 0.16 respectively. This isn't a personality judgment, but rather clear, actionable habits that can be addressed to improve the score. Here we have the core of our AI credit scoring system implemented in a simple web application using Flask. The key point is that the saved model is loaded once when the server starts, so users never have to wait for any training process. When someone submits the form, the application processes the input by converting it to a data frame, then it predicts the probability of a certain outcome using the model. It also generates the top reasons explaining that score. Both the score and explanations are then seamlessly displayed on the results page. Notice what's missing: there are no hard-coded rules or thresholds, no if statements about dating or credit. All the decision logic lives inside the model file itself. This design makes the system highly flexible. If we switch to a completely different dataset tomorrow, the code here doesn't need a single change. Here's what the model says about each person, based on their behaviors and scores. Male A scores a high 0.86 because his reply gap never exceeded an hour, showing great consistency in communication. Female B scores 0.74, mainly due to taking care of her outfit on every date, indicating effort and presentation. On the other hand, male C scores just 0.19, since he always replied the next day, which is quite slow. Interestingly, female D, who actually answers the fastest, scores only 0.31, while male E, who takes about 3 hours to reply, scores a higher 0.62. This shows that speed alone wasn't the key factor. Consistency and showing up with intention were much more important here. Let's take a closer look at female D's case next. Here we have a detailed look at a specific case from our AI credit scoring system, identified as female D. Her second date probability stands at just 0.31, which is quite low considering she sends 18 messages a day and responds within 5 minutes. Yet, she hasn't secured a second date. Now, the AI model uses SHAP values to pinpoint the top 3 reasons affecting her score. The heaviest factor is outfit care, with a negative impact of -0.24. This means she never adjusted how she presented herself, which counts against her. Next is reply gap, -0.16. Her responses are quick, under 30 minutes, even late at night and early morning, which the model interprets as availability rather than genuine interest. Lastly, messages per day weighs in at -0.11, where sending 18 messages a day comes across as pressure instead of enthusiasm. What's truly fascinating is that no one would have said these things directly to her face, but the model delivers them clearly in just 3 lines, each accompanied by a numeric weight. It's a powerful example of how data reveals insights we might otherwise miss. Here's the payoff from applying our AI credit scoring system. We adjusted 3 key behaviors and rescored the model. First, putting consistent effort into every date, not just the first, increased the score from 0.31 to 0.52. Next, extending the reply gap to 2 to 4 hours instead of 30 minutes pushed it further to 0.67. Finally, reducing the number of daily messages from 18 down to about 6 raised the score to 0.78. This shift from unlikely to very likely happened without spending any money. What this demonstrates is the power of an explainable model. It doesn't just give a verdict, it provides a clear, actionable to-do list. Here on the screen is the AI credit scoring system in its simplest form. You just fill out one form and press the button, and it instantly gives you one score along with 3 key reasons explaining that score. There's no complicated dashboard, no confusing charts to interpret. On the right, you see the components that make this possible. The train_model.py script handles loading the data, training the model, and generating the SHAP explainer. Then, webapp.py runs the Flask server and displays the results page. The dating_model.pkl file is the trained model, ready to be loaded in about a second. Finally, the dating_records.csv contains the sample data used for this demo, so your first run will match exactly what you see here. And if you want to dig deeper, the full source code is available on GitHub, just check the link in the description. This setup makes it incredibly straightforward to understand the score, with clear transparency behind each prediction. This is patent number 7791512 doing a job it was never advertised for. A bank asks whether you will pay it back, and we asked whether she would text back. Same engine, and it answered both. Next up in this series, Volume 3 will focus on quantum anomaly detection, using the very same explainable approach to spot transactions that shouldn't be there. If this was helpful, please subscribe and grab the code, all available on GitHub, with accompanying books on Amazon KDP, both linked in the description. Take care of yourself out there, and here's hoping the next reply comes fast.